Hello everybody, if you're using Node.js, you know that Node.js works with some great ORM libraries such as Sequelize, TypeORM and Prisma, and today we're going to talk about Prisma since it is currently one of the most used ORMs and it is good to know more about it. Before explaining Prisma, you may ask yourself, why do you even need ORMs? Well, let's say you need to create a user and you know what that user consists of, for example, first name, last name, email, etc. Since we are using Node.js and Node.js is built on JavaScript, if you want to store this user in JavaScript, you will use objects. But if you want to store this user permanently in database, you will need something to connect your application to the database itself. That something is ORM, and ORM system will help you do that. One more reason why I'm making this video is to see how easy it is to build CRUD application using Node.js, TypeScript and Prisma, and what benefits we have from using it. In this video, we're going to talk about Prisma schemas, how to migrate changes from models into database, how to preview data in modern UI, how to make indexes in order to make your queries faster, what type of SQL relationships Prisma supports, and at the end, we're going to see how it is easy to make CRUD application using Node.js, express.js, TypeScript and Prisma. So, without further ado, let's start with the video. Prisma provides an abstraction that allows us to write database queries using JavaScript or TypeScript. Prisma then maps the queries written or a chosen language into the database of our choice, which makes it easier for developers because we don't have to write queries in the database language itself. Prisma is built on so-called object-oriented paradigm. Currently, Prisma supports MySQL, SQLite, PostgreSQL, SQL Server and MongoDB. One of the primary reasons why Prisma is so popular these days is because it consists of three major tools. First of all, we have Prisma Client.js, which is a type-safe and auto-generated database client. It is a so-called ORM replacement. Second of all, we have Prisma Migrate, which is a declarative migration system with custom workflows. And last one is Prisma Studio. It's a modern admin UI to support various database workflows. Let's break it down. Prisma Client, like I mentioned previously, is a type-safe database client that replaces traditional ORMs such as Sequelize, Bookshelf and Mongoose. It allows us to access the database through plain JavaScript methods and objects without having to write the query in the database language itself. This is the part that actually acts as an abstraction in front of the database, so it's much easier to write CRUD applications. Prisma Migrate, on the other hand, is a powerful database schema migration tool. It uses a declarative data modeling syntax to describe our database schema. Prisma Migrate stores our entire migration history and easily lets us revert and replay migrations. It also allows us to run before and after hooks to execute scripts while migrating, so basically we can populate the database with required values during a migration. Prisma Studio allows us to visualize data via an admin UI. Here we can perform CRUD operations on our data. This is the easiest way to visualize data from our database as well as manipulate it. Okay, let's install Prisma. But before we install Prisma and all of the necessary dependencies, we'll need to set up the Node.js TypeScript starter project. Here I am in a Visual Studio Code and I'm going to open a new terminal by clicking on a new terminal. Before this part, also create a new folder where you will do all the work. I have already done that and it's called Prisma CRUD. Next, we'll set up the project package.json and add the dependencies. Using the Y flag when creating a package.json, we simply approve all the defaults. We are first going to add all of the dev dependencies. TypeScript is going to be added as a dev dependency, and we are going to add one more dependency called tsNodeDev, again as a dev dependency. tsNodeDev is basically a package for Node.js that restarts Node server when any of the required files changes, but it shares TypeScript compilation process between restarts, and this significantly increases the speed of restarting server comparing, for example, to NodeMon and tsNode variations. Let's install those dependencies. So we are going to install them by running this command npm install TypeScript tsNodeDev, and like I mentioned previously, we're going to install them as a dev dependencies. As you can see here, we added them as a dev dependency. After we install TypeScript, we get access to the command line TypeScript compiler through the tcc command, but more on that later on. I'm going to install Express as a dependency also because we will need Express to run our server. As you can see here, we installed Express as a dependency, not only as a dev dependency. Since we are using Node and Express, it would be good if you could get type safety and auto-completion on the Node and Express APIs like file, path, process, server, and many more. That's what installing the definitely typed type definition for Node and Express will do. Well, how to do that? We're just going to run this command: npm install @types/node and @types/express. But again, we only need this on our dev environment, so we're going to install them as a dev dependencies. Next up, we'll need tsconfig.json file. The tsconfig.json file is where we define the TypeScript compiler options. We can create a tsconfig file by running the following command: npx tcc//init. This is just a flag which is going to initialize a tsconfig.json file. If you have installed tcc as a global dependency, then you do not need npx in front of it, but I haven't do that, so I will use it here. Let's press enter. At this point, you should have a tsconfig.json file that looks like this. As you can see here, we have a compiler option objects, and inside this object, we have a tons of fields that we're going to change. We can go ahead and clean the commented out stuff that we don't need. Our tsconfig.json file should look like this. Okay, let me explain this. Root dir. This is where TypeScript looks for our code. We have configured it to look into the source folder. That's where we will write our TypeScript. Out dir or out directory. This is where TypeScript puts our compiled code. We want it to go to a build folder. ES module interrupt. This is a complicated topic and it basically requires much longer discussion. And so if you are using CommonJS as our module system for Node application, we should be, then we need this to be set to true. Resolve JSON module. If we are using JSON in this project, this option allows TypeScript to use it. We are not going to use JSON, but let's leave it here. Lib. This option adds ambient types to our project, allowing us to rely on features from different ECMAScript versions, for example testing libraries and even the browser DOM API. We would like to utilize some ES6 language features, but this all gets compiled down to ES5 after TypeScript builds it. Module CommonJS is a standard known module system, and we're going to leave it here. No implicit any. Basically, in TypeScript files, we do not allow a type to be unexplicitly specified. Every type needs to either have a specific type or be explicitly declared any. And that's why we need it here. Inside the script objects in package.json, we're going to add a new comments. Let's delete this. And let's write our own comment, which is going to be start dev. This comment is going to be run by tsNodeDev. And we're going to add another command, which is going to be called build. Okay, let me explain this. I'm adding the start dev command to start our server and to also restart it if there are any changes on required files. Next to command tsNodeDev, I am adding, as you can see, two flags. One is respawn, another one is transpile only. Respawn, which is required, and additional transpile only, which is good to use for large code bases and basically will speed up things greatly. This last argument to this command tsNodeDev is the file we are pointing to, basically the file which server will be run on, and our server will be run on the file server.ts, which is going to be in the folder source. Command build will only run the TypeScript compiler, which is going to build our project in an out directory, which we specified here. Okay, next step, inside the script object in package.json, we're going to add a new comments. We're going to delete the comment test and add the comment start dev. This comment will be run by the tsNodeDev package, which has two flags. One is respawn and one is transpile only. And we're going to add also a last command, which is going to be called build. And it's going to be run by the TypeScript compiler. Okay, let me explain this. I'm adding start dev command to start our server and to also restart it if there are any changes on required files. Next to command tsNodeDev, I'm adding two flags, respawn, which is required, and additional transpile only, which is good to use for large code bases and basically it will speed up things greatly. This last argument to this command is the file we are pointing to, which server will be run on. Our server will be run on the file server.ts, and this server.ts file will be in the source folder. Command build will only run the Typescript compiler, which is going to build our project in iDirectory that we previously described in tsconfig.json file. Okay, let's test it. Everything works like it should. We should create a new folder called source, and inside this folder we should create a file called server.ts. Let me make that, and let me make a file called server.ts. Inside this file, let's for example console log something, hello world. And now we should run our command from the package.json, which is start dev. And to run command from the scripts object inside package.json, we write first npm run and then name of the command, start dev. And as you can see here, everything works fine. We have console logged hello world in our terminal. Okay, let's set up Prisma. First, we need to install Prisma as a dev dependency. Previously, we used to install Prisma as a global dependency, but that is not recommended anymore. Let's write npm install prisma /save dev and run the command. Okay, as you can see, the Prisma has been installed as a dev dependency. Now, in order to initialize a Prisma project in our directory, we should use the following command, npx prisma init, and there's an additional flag which is called data source provider. Data source provider flag is not necessary, but it will speed up things for setting up the Prisma. If you're using any other database, just write that instead of SQLite, which I'm going to write. For example, you can write MySQL or PostgreSQL or SQL Server, whatever. Let's press enter. And now, as you can see, we have a new folder and a new schema.prisma file inside that folder. Okay, go ahead and remove all of the comments and change the contents of schema.prisma file to the following. First, we're going to delete all of the comments because we don't need them. And beneath the data source block, we're going to paste the two new models. Now, let's break it down here. The schema.prisma file contains the data model as well as the configuration options. But before we do anything else here, I would advise you to install Prisma extensions inside the Visual Studio code called Prisma. This adds syntax highlighting, linting, code completion, formatting, job to definition, and more for Prisma schema files. The data source block is used to specify the connection to the database. We set the provider field here to SQLite. Basically, SQLite is embedded database software that can be used anywhere. It allows us to create a local database without having to install anything. URL field contains the connection string to our database. Here we can either choose to type the connection string, which will be seen by everyone, or to use a better approach, which is in environment variables, like it has been using by specifying the data source flag when initializing the Prisma project. As you can see here, when we use the data source provider flag, Prisma will by default create a .env file. Whatever we type after the file here is the name which the database gets created. In our case, the database will be created in the Prisma folder with the name not dev but devbit.db. Let's save the environment file. Generator block. By adding the generator block, we specify that we want to generate Prisma's database client. This client is generated by running the Prisma generate command and will be located in the node modules at Prisma. We're not going to open that right now, and it can be imported as import Prisma client from @prisma/client. We're going to see that later on. Here we have two models, or so-called model blocks. Here we define the user data model using the model block. Models represent the entities of our application domain. Basically, on a technical level, a model maps to underlying structures of the data source. For example, in relational databases such as SQLite and PostgreSQL or MySQL, a model maps to a table, whereas in a non-relational databases, for example MongoDB, it will map to a certain collection. Here inside the model user, we have three attributes, namely ID, first name, and last name. The ID field is a primary key of a type string. I'm going to explain much later on what these three here attributes means, but let me just break down the model user in general. The ID field is a primary key of a type string with a default value of collision resistant IDs. My advice to you is to use this instead of using any other IDs, because collision resistant IDs are optimized for horizontal scaling and binary search lookup performance, basically better performance acquiring your database overall. To determine which field of a model is an ID, we can annotate it with using @id attribute. We will talk about data attributes like I mentioned previously in data annotation later, so do not worry about these things right now here. The first name and last name field is a type of string. Finally, we define the car model. The car model contains 4 fields. First one, basically any model needs ID, and car also has ID. It has color, which is a type of string. It has both, which is a type of boolean, and its default value is false, and name, which is a type of string. Now, to add Prisma Client to the project and to utilize everything that Prisma offers us, we need to use the npm, and to install it, we can use the npm command npm install at Prisma Client. In order to generate the Prisma Client, we also need to type another following command, which is npx prisma generate. And as you can see here, you can now start using Prisma Client in our code. And this is the code that I also mentioned previously about how we can import Prisma Client. One more super important thing to mention: if we didn't have any models here and we run the npx prisma generate command, it would fail because we couldn't generate anything. So basically, when we type the command npx prisma generate, that command will look our schema.prisma file, and it will see what models we have, and on those models it will create types, methods, and etc. You will see that later on. So basically, if you want to generate Prisma Client, please make sure to first create models and then run the command npx prisma generate. Now let's talk about how Prisma handles the relations inside the SQL relational databases such as the SQLite. First, let's open the schema.prisma file and check an already built car model and already built model user. For our application, let's say each user is supposed to optionally have one car, and each car must have one and only one user. This is called one-to-one relations in SQL. First, let's create a one-to-one mapping between the two models. Inside the model user, we're going to create a new field called car, which is going to be of type car. The question mark at the end denotes an optional honorable field. We will see later on when we do migration what this means. On one side of this relation, we must add ID field for referencing, because in reality it only makes sense to first create a user entry and then link a car to it. We'll add a user field inside the model car and add a relation attribute again in the model car. So we finish with the model user. We created the car, which is going to be a type of car, and that's it. And if you hover over it, the problem, as you can see, the relational field car or model user is missing an opposite relational field or model car. That's why we need to create two new fields here. First field is going to be, like I mentioned previously, user ID, which is going to be for type string. And the relational attribute, to write relational attribute, first type the name of a field, then the type, and the relational attribute starts with @relation. Now hitting the control space in VS Code will give us some hints as of what we can put in here. The first thing we'll need is the fields on this car model we want to use for mapping. This is going to be our user ID field that we just created. This user ID field is also called relational Scalar field. So let's press here fields, and inside this array just type user ID and comma. The second thing here is the unique field on the other side of relation. Our other side of relation is this model user, and the only unique field here is the ID, because one user can only have one specific ID. So let's type our references and add ID. But again, as you can see, we still have an error. In this case, we need to mark this field user ID with a unique attribute to guarantee that there is only a single user connected to each car. So let's add that, and we fixed all of our errors. We are going to talk about later on with the data attributes and data annotation regarding the @unique, @default, and etc. So don't worry about that. Okay, let's talk about now one-to-many relations. In our application, user can create car blocks on this application. So let's create a new model for car blocks with a creation timestamp and add a list called car blocks on the user model to create the relations between them. Okay, let's create model car blocks, and inside model car blocks, let's type the ID. I'm going to delete everything else here, but thank you GitHub Pilot. Then I'm going to type a field string on the content of a type string. And the last is created at, which is a type of date time, and the default value is now. Let's save it. Now inside the model user, we're going to add a new field, which is going to be of a car blogs and a type car blog. I forgot to mention here, let's leave it like this. And again, we have the same problem as we had previously. So inside the car blog, we're going to add a user ID of a type string, and again the user field relation attribute with the type of user, and that's it. In order to explain one-to-many relation properly, this array modifier here marks the field as a list. So this means that the user can have many blocks created about cars, and that specific car block can only have one user. Many-to-many relations refer to relations where 0 or more records on one side of the relation can be connected to 0 or more records on the other side. In relational databases, many-to-many relations are modeled via relational tables. Here in Prisma, many-to-many can be created either explicit or implicit way. In an explicit many-to-many relation, the relational table is represented as a new model completely in the Prisma schema and can be used in queries when fetching the data from the database. Explicit many-to-many relations basically define three models. Two models that have a many-to-many relation, such as car blog, and we will going to create a new model called category car blog. And also there is a third model that represents the relational table, such as categories on the car blogs, also sometimes called the pivot table in the underlying database. So let's make up a new situation to say that our car blogs model can have a multiple categories inside, and that multiple categories can also have multiple blocks assigned to that specific category. This is a basic system of tags that you could see on any social network, for example. We're now going to create a new model, and also we need to change already existing model in order for this to work. So let's do that. As you can see here inside the model car blog, we created a new field called categories of a type categories on car blogs, which needs to be type of array. And inside the category car blogs, we also created a new field called car blogs, which is going to be of a type, again, categories on a car blocks array. And we created a completely new model categories on car blocks. At ID annotation is used to define IDs, and it is super important to add it inside this new pivot table to make it work. Why is it called the pivot table? Well, we have the two IDs from the two models that we want to connect. And how to connect all of these three models? Well, inside this pivot table, you need to have, like I mentioned, the IDs. And as you can see previously in Prisma, I explained in order to connect two models, you need the @relation attribute, and you also need the ID, which is going to be used here inside the fields. And that car blog ID, for example, here is going to reference the ID from the car blog model. That's why it needs to be of a type string, because this is the type of string. If you put here int, it will not work. First of all, we're going to have an error here, and then we're going to have another error here. So that's why we're going to stick to the string, because it works. And again, we added the new ID, but this time we are not referencing the ID from the car blog. Instead, we are referencing to the category car blogs. And these are the two important fields inside this model. The optional fields, you can add whatever you want. I added signed at, which is a type of datetime, and I added a signed by, which is a type of string. Now here, the at ID annotation is used to define IDs, and it is super important to add it inside this new pivot table to make this many-to-many explicit relation to work. Implicit many-to-many relations are much easier to understand, and they define relational fields as arrays on both sides of the models. Although the relational table exists in the database, also called the pivot table, it is not managed by us. It is managed by Prisma and does not manifest in the Prisma schema, so we are not creating it. Implicit many-to-many relations makes the Prisma Client API for many-to-many relations a bit simpler. So now we're going to create a new fields, and they need to be a type of array, like I mentioned it. So inside the car blog, model, we're going to create a new field of a type categories, and it's going to be of a type category car blocks, and it's a type of array. And then inside the category car blocks, we need to add another field which is going to be of a type car block, and there you go. As you can see here, it is much simpler to use implicit many-to-many relations, and I would advise you to use this instead of using the explicit many-to-many relations. A relational field can also reference its own model. In this case, the relation is then called a self-relation. Self-relations can be of any cardinality, one-to-one, one-to-many, and many-to-many. Note that self-relations always require the @relation attribute. I'm going to add two new fields inside the user model. Let's add friend of a type user and a question mark to make it optional or nullable, and add relation attribute. Also inside the @relational attribute, you can add a custom name. So basically the Prisma, we're going to create a custom name for us, but you can change that custom name by first, before adding the fields and the references, you can add a string here, which is going to be a custom name for our relation. Let's add here friend. And now let's type, before this, I'm going to add a friend ID of a type string, and I'm going to make it optional. I'm going to explain it why it needs to be optional, and also I'm going to add it to be a unique field. Now inside, let's get back writing here inside the fields array. I'm going to add a friend ID, which is going to reference the ID here. And also let's add one more field. It's going to be a type of friend of, and again, user optional field @relational friend. Okay, this relation expresses the following. A user can have 1 or 0 friend of. For example, John is a friend of James, and user can have 1 or 0 friend. For example, John is James' friend. One-to-one self-relations cannot be required on both sides. So if I delete the optional mark here, this is going to fail. This will not work. So I need to add it on one or both sides. Must be optional. Otherwise, like I said, it becomes impossible to create the first user record. To create a one-to-one self-relation, there are a few steps. Both of the side of relation must define @relation attribute that share the same name. Like I mentioned previously, you can create a custom name, and this is the custom name. In this case, it's friend. One relation must be fully annotated. In this case, it's a friend. One relation must be backed by foreign key. The friend field is backed by foreign key, and this is the friend ID, which references a value in the ID field. The friend ID field also requires @unique attribute to guarantee a one-to-one relation. If you do not put this here, there will be errors when trying to get the data from it. One more thing to mention, there is another parameter to the annotation relational attribute, which is called referential actions. They determine what happens to a record when your application deletes or updates a related record. In the following example, adding onDelete cascade to the car blog user field means that deleting the user record will also delete all the related car blogs relating to that user. So let's add that. We're going to add onDelete cascade, and that's it. We finished with talking about types of relations inside the Prisma. If you did not understand it properly, please let me know down in the comments below. Also, Prisma documentation is a good place to learn more stuff about not only relations but Prisma in general. Fields in Prisma are really important to understand. Properties of a model is called field, and in most cases it consists of a field name, must start with a letter, and in most cases it is spelled in camel case, a field type, optional type modifiers, and optional attributes including native database type attributes. A field's type determines its structure and fits in one of the two categories: a scalar types, including enums, that map to columns or a document fields in the database, for example string, int, boolean, big int, and many more. Model types, the field is then called relational field, as you can see here. For example, car blog or car blog array, and etc. As the Prisma documentation says, attributes modify the behavior of fields or model blocks, so you can basically change what certain field in your model does. Fields are equivalent to columns in SQL databases. Some attributes will need arguments. For example, add default accepts an argument, which can be whatever the type of the field is. In this case, if it is a string, we can define the default value to be whatever string we want. If it's a type of boolean, we can either be the default value can either be true or false, and etc. An important thing to mention is that we can define also functions as an argument which will return the value, such as the constant resistant IDs function and auto increment function for specifically IDs. While we are on the topic of an ID, what's an ID in database? An ID uniquely identifies records of a model inside the database. For example, there can be only a single car with a specific ID. In relational databases, the ID can be a single field with or based on multiple fields. If a model does not have an @id data notation or an @ID data notation, we will see that later, you must define a mandatory @unique field or @unique block instead. In the following example, the car ID is represented by the ID string field. This means that the car will be uniquely identified by the single field ID, but there is a thing called composite ID, which means that the model will be represented, for example here, by combination of the fields. For example, we can make it to be @ID, type name, and color. But if you do decide to use composite IDs, then you do need to delete this here, and as you can see here, everything works perfectly fine. You do not need to use the ID annotation like I mentioned it previously. You can choose a @unique field for defining uniquely identified records, but if you do opt to using this, which I do not recommend, you will then need to make that field non-nullable, otherwise it will not work. So inside this model car, I want to make this column string an ID with the @unique data annotation. So let me just type @unique. One thing to mention, you cannot use the foreign key ID as the primary key ID. There can only be one foreign key or one primary key. You can define default values for Scalar Fields of your models using the @default attribute. Default values can be static values that correspond to the field type, such as 5 for int, hello for string, or false like we have here for boolean. We can also use list of static values such as 5, 6, 8 for int array of a type, or hello goodbye of a string array type. These are available in versions 4.0 and later, and in databases that support list values such as PostgreSQL. We will not be using these because it will not work on SQLite. And we can also use functions such as toID or now. You can add unique attributes to your models to be able to uniquely identify individual records of that model. We already explained the unique attributes, and they can be defined on a single field using @unique attribute, or on a multiple fields, which if you do remember is called a composite field using the @unique field. So inside here, let's add the @unique field for the first name and last name. You can also define indexes on one or multiple fields of your models via the @index on a model or @index for a single field. Indexes in databases are really important if you do have problems with performances. Prisma will not create a sloppy query if you do think that, but sometimes you will need to use the indexes, especially if you query the data by a specific field. You do not need to add the index on primary key because the database itself will do that for you. Again, you can add it on a single field or create a composite field. And in order to show you how to create an index, you just type the @index here and just, for example, choose fname, and that's it. You can even create a composite index. For example, we can add the fname, then the lname, and we can name this index, for example, the fname and the lname combination. Prisma is so powerful that you can define enums in your data model if enums are supported either natively or at Prisma level. You will often use enums if you, for example, are making authorization and authentication functionality, and especially if you are in need of a roles for a specific user. We can create a new enum, for example, role, and inside here we can create the admin and user fields. And inside the model user, we will create a role of a type role, and the default value will be user. If you paid attention to what I was saying throughout this video, you could hear me talking about Scalar Fields. There are tons of Scalar fields supported by the Prisma, but one of the most used are string, boolean, int, big int, float, decimal, JSON, etc. If you, for example, write string as a field type, Prisma will map the string to the native database type attribute. In this case, string will be mapped to a text field. If you do want to specifically map the field type to the native database type attribute, you can do that by typing the following annotation. For example, first name is a type of string, but we can type it to anything we want. For example, db.varchar 255. This would work, but native type varchar is unfortunately not supported for SQLite connector. If you do want to search more about how you can map the different Scalar fields to a different native data type attributes, then you can check the description down below, and there will be a link to a Prisma Schema API for the reference. Benefits from using this is that you can then control the exact native type that Prisma Migrate creates in databases. Last thing to mention is type modifier, but we already touched this topic earlier. The type of a field can be modified by appending either two of modifiers. Make a field a list if you're using array, or make a field optional. You cannot combine these two type modifiers. Optional lists are not supported currently. We created new models today, and it is time now to migrate these changes using the super powerful Prisma Migrate. In order to migrate the changes from the schema.prisma file to the database, you can type the following command: npx prisma migrate dev. When you type this command and wait for a little bit, you will be prompted to enter the name for this migration. Please, when you are typing the name, make sure the name for the migration is long enough to understand it. For this demo purposes, I'm going to call it first migration on dev-bit channel. There you go. We created our migration and we successfully created our database. Since I show you how to migrate the model changes into database, and I already mentioned about the Prisma Client, now it is time to show you how to add and see the data in modern UI or graphical user interface. Open your terminal and add this command: npx Prisma Studio. We will now be able to open the studio, which will be hosted on the port 5555. As you can see now, we are able to see all of the models we created and the recently opened ones, if you already opened Prisma Studio before. Click on whichever you like. I will click on car. But important thing to mention here is that you need to do all of the migration before opening the studio. Once you have clicked on the certain model, for example I click on the car, there is a button with the label add record, which will help us to create a new record very easily without making the files for seeding purposes. If you do want to make a file for seeding purposes, what you need to do is to inside your main folder, in our case it's a source folder, create a new file called seed.ts, or call it whatever you want, and copy the following code. First, we have imported the Prisma client from the Prisma Client package, which was generated from a schema Prisma file when we ran the npx Prisma generate command. Next, we create a constant called Prisma, which is an instance of a Prisma client. We have an async function called main. When calling the main function, if any error occurs, the catch block will catch the errors and will display them with the console.error command, and whether an error happens or not after the running the main function, the code block inside finally will run. So for example, if I type here console log it starts seeding, for example, inside the terminal, then you need to install the following package called tsnode and install it as a dependency. Then you can type the following command inside the terminal: npx tsnode source seed.ts, or the name of your file for seeding, and that's it. In Prisma Studio, I've opened the user model, and inside the user model, now I'm going to create a new record. In order to do that, I'm going to click on the add record button, and now we need to type the values here. Inside the ID, we do not need to type anything because we opened the schema.prisma file, and inside the model user, as we can see, we have the default value of collision resistant ID. Inside the first name, we can, for example, type dev, last name bit, car is an optional field because we do not need to have a car as a user, so we do not need to click anything here. Car blocks, again, this can be either the 0 or whenever we create a new car block, then we can add it inside here. Friend ID, we do not need to have a friend. Again, friend, we do not need we do not need to be friend of anyone, and friend of, again, same thing. Let's click save and change. That's it. We created a new file, or a new entry to be more precise inside the database, and the ID is collision resistant ID. Now let's get back to the car model, and I'm going to create a new car to just show you how this works whenever you have a foreign ID key. Inside the ID, again, we do not need to type anything here. Color can be blue, bold can be false because the default value is a false, name can be Audi A5, and now inside here you cannot type anything here because we do not know the user ID, especially if we are using the collision resistant ID, which is a string that has many characters and it's impossible to remember it. So we can click on this user here and it will open a new tab or a new drop down menu, and inside here we can select this here and we can open it in a new tab if we want, but we do not need to do that. I'm just showing you that. So we can just select the user here and that's it. We can now click on save, and we can click on, first of all, click on the exit out of this menu and then click on save and change, and that's it. Now we have a car. Now this user has a car. As you can see here, when we click on this, it's connected to the Audi A5. This has been a short crash course of Prisma. If you do want me to create a completely full-fledged full-stack application using Prisma, where I will show you how to create a database that is scalable, then make sure to comment down below. It is now the time to create a simple CRUD application and to see is it easy to make one using Prisma, Node.js and express.js. This is not a tutorial on how to make the best REST API ever. This is just a tutorial on how to use Prisma and Node.js and express.js. If you want me to make a real-world project using Prisma and Node.js, please let me know down in the comment section below. Also, before we start, I realized I made a mistake when showing the tsnode dev package and command. I accidentally undo the installing of the types for Express and Node dependencies, so please make sure to do that. One more thing to add is another flag inside the tsnode dev command, because I initially didn't want to focus on making a better structure of REST API in this video, but I realized why not. So that is why we need to add a new flag here, which is called exit child. This flag here is important because we're going to use multiple files, and those files will act like children to the main server.ts file, and you will see why. Okay, now we're going to create a new file called app.ts, and we're going to create it inside the source folder. Here we're going to create a new class which will have this structure. Okay, let's save it. Then next we're going to use the already made server.ts file, and we're going to import this class here to this file. Let's do that. We're going to import, and we can name it whatever we want because we are exporting as this class as a default. So let's name it app from app, and here we're going to create a new server, but first we need to use the port. First we need to create a port, a variable for our port, and then we can use the already built method inside the express.js, which is called listen. The first parameter to this function is the port, and the next parameter is the callback function that we can use to basically just write something to our terminal that this server is running on this port. To explain how this works, when we export the file, we export it as a default, like I already mentioned, and we are automatically creating a new object whenever we export this file using the new keyboard, and we are getting the public variable from this class called public server. This public server variable is initialized in the constructor. Every class needs to have a constructor, and inside our class we are initializing this public server variable to express method, which is able to create us a new server and to basically use middlewares and everything that is important from the express.js package. Also, we are initializing the methods middlewares and routes. Middlewares are important for the express.js application. Here we are using all the built-in middleware from the express package called express.json. We need this package here in order to use the request.body inside our routes and controllers. You will see that later on. And here we have the method routes. Inside this method we are going to again use the use method from the express to basically initialize and create a new routes, but you're going to again see that later on. As you can see now, I have split the responsibility from the server.ts file to the app.ts. In general, avoid the nasty habit of defining the entire Express app in a single huge file. It is better to separate your Express definition to at least 2 files, the API declaration, which is going to be in our app file in a class app, and some other stuff, for example, networking concerns. For even better structure, you can locate your API declaration within components, but today we'll not do that. Okay, now we're going to create a new folder called routes. And we're going to create a new folder called services. Inside the services, we're going to create a new file called prisma.ts. Basically, we're going to initialize the object from the Prisma Client class here, so we can use this object wherever we like to use it. In order to initialize it, you need to import the Prisma Client class from the Prisma Client package. We can then initialize the object by using the new keyword in the class, and let's export it as a default, so we can name it whatever we want when we are importing this variable here in another file. Okay, that's done. Inside the routes folder, we're going to make a new file called index.ts, but I'm not going to use that file now. And now we're going to create the 3 new files: user.routes.ts. We're going to create another file called carroutes.ts and carblogs.routes.ts. Future debit here. I know I told you to make 3 routes file, but if you watch the video to the end, you will see that I did not touch them besides the user.routes.ts file. You may ask, well, what is the reason for this? The reason is that is the task for you. I want you to watch the video to the end and make the exact same methods just for the different models, not the user one, and use the methods from the Prisma to just get better at remembering them and to be just better at the Prisma in general. Okay, back to the video. Here inside the user.routes.ts file, we need to initialize the router from the express.js so we can make a new endpoints and basically just make a new routes. How to do that? Well, we need to import router from the express, and then we need to create a new router, or basically I'm just going to name it routes because it's easier for me. And then on this variable here, we are basically now, which is a type of router, we have a few methods. When we press dot and control space, we have a method for get request, post request, and everything else. We will use the get request because this first endpoint we are making is for getting all of the users from our database. Now the first parameter to this function get is basically the endpoint, and I'm just going to name it here to slash, and you'll see later on why. And the second parameter is the callback function, which has 2 parameters, request handler and response handler, but I'm not going to do that here. What I'm going to do next is create a new folder called controllers, and inside this folder I'm going to create a user.controller.ts, and here I'm going to export an object called user controller. I'm just making a JavaScript object, and then thanks to GitHub Pilot, basically I can do this. This is a method the same way. For example, I can do this, what I did here, I can do this inside here, but like I mentioned earlier, it is better to separate things. Basically, I'm making a function called index, or a method inside an object, which has 2 parameters, one is request and one is response, but we need to import the types for this so we can use this. And also, as you can see here, we do not have a Prisma file, but if you do remember, we made a services folder, and inside that we made a Prisma file. So let's import Prisma now from the services.prisma, and I'm going to explain this later on. Let me just finish making of user routes. Now inside the controllers, we have a user.controller file, and we're going to import user controller object because I exported it as a const. As you can see here, that's why we need to use the curly braces. And let's use the method called userController.index. Well, we made a new endpoint and a new route with the get request, but how can we get this request, or how can we access this endpoint? First of all, we need to import the user routes from user that routes. But if I do not, yes, I haven't exported, so let me do that. We just need to export these routes, and again, I'm going to add a new routes inside this file, but we will do that later on. Let's export this file user routes, and now inside the app.ts we're going to import user from routes. How do we make a use of our routes? In this case, user routes router module that we imported from the routes folder. Well, inside the routes method in this class app, we already have a server that uses middleware, which will help us do that. We first need to specify the starting path for all of the routes inside the user.routes.ts file. So our starting path will be API/users, and now the second parameter means that when a user hits this route/API/users, the routes from the user routes file, so that's why we need to write this here, will be run, but depending on a method that user requests the endpoint with. Okay, now in order to test if everything works perfectly fine, we need to start our server. In order to do that, let's run the method npm run start dev, which is going to run our server. As you can see, server is running on the port 3333 from the server.ts file, and we created the port variable here, if you do remember. Now, in order to test if our endpoints are working correctly, I'm using Insomnia. Insomnia is really cool application for API testing and etc. If you do not like using Insomnia, then you can use Postman or Swagger, whatever you like. I'm going to create a new HTTP request, and I'm going to write our base URL, which is http localhost and on the port 333. And now I'm going to hit the route API users, and the request is going to be the get request. Let's click on send, and as you can see here, everything works perfectly fine. Now, in order to explain this, we are getting our user back. We will get multiple users, but since we only have one user in a database, we only get one user. This is the case because inside the user.routes.ts file, we are using the user_controller.index method from the user.controller.ts file, and inside this index method, we are returning the user from the method prisma.user.findMany, and we are returning our user as in JSON format. Now, in order to create a new user, I'm going to create a new method inside the user control object. That method is going to be async, and it's going to be called createUser, again with two parameters, request and response. Now, inside this method, I'm going to be using the request.body object. Request.body object allows you to access data in a string or JSON object from the client side, and you're basically going to use the request.body object to receive data through post and put requests from the expert server. I'm going to initialize the user data variable to use the request.body. In order to create a new user, we're going to use the Prisma object from the Prisma Client class. I'm going to type the const user await. Now, the reason why we are awaiting any method from the Prisma, because Prisma, that for example that user.find is going to return us the promise, Prisma promise, and in order JavaScript to get the value from the promise, you need the await keyword, or you can use that then promises, but I like the await async approach much better. Now, when we type Prisma dot and press Ctrl space, you're now going to see tons of options. The most important options to us are the properties on the Prisma object. These are the models that we created in our schema.prisma file here. So I'm just going to use the prisma.user because we are just going to need it here, not any other model. When we type prisma.user dot, again, Control space or Command space, you're now going to see tons of new methods from the Prisma object. In order to create a user, we're going to use a create method. This create method here has tons of arguments to this method, but the most important one is the data. The reason why data is important because it is required. Now inside this data object, when you again press Control space, you will now see again the properties, not properties, but like fields from the user module. I'm not going to type the f name, but the reason we are using the request.body is because I'm not going to write anything static here, for example that one, because that would not make sense. So I'm now going to use user data.fname, and the last required field in our model for a user is last name. So again, I'm going to type user dot, at this time lname. Now in order to return this to user, I'm going to just use the rest.json method from the Express server, and I'm going to return the user object. Now as you can see here, I only wrote fname and last name. The reason why I didn't wrote anything else, even though we have tons of more fields inside here, fields that are marked as optional have default values, we do not need to write them because you don't need to have a car because it's optional field. Car block is array, that can either be of a value 0 or more, and friend ID is again optional, and ID, even though it's not optional, it has default value of a collision resistant ID. So now let's check if this works, but before that I created a new request which is hitting the endpoint /API/user/create, but I need to create that endpoint inside the user.routes.ts file. So I'm going to create a new route, post/create, and user controller.create a user. Now inside here I'm going to click on this body dropdown and click on JSON. And now inside the JSON, I'm going to type the first name to be, for example, dev1, and lname, sorry, I forgot to use this here, is, for example, bit1. And that's it. I'm going to save it, click on send. And as you can see here, we created a new user of a ID, first name, last name, and friend ID is a null value because it is optional and we didn't write anything in our create a user method. We also have a select include arguments to select which properties of fields to include a return object, and include means that we need to specify which relations should be loaded on return object. Even though include is an optional field, if we do not write what relations we want to return, Prisma will not return us those properties in JSON format or any other, because we have to specify that. And as you can see, we only return the first name and last name. And if I want to include something on that return object, I just type the include here. And for example, I want to include a car, like I mentioned, just type include car true. So let's create a new user, for example, dev2 and bit2 send. And now we have include car in our return object, but we didn't create a user with a car, so that's why the value is null. If we now go to get all user, click on send, we will now have 3 users inside our return object. Now in order to return a specific record from the database, we can use the method called findUnique. But before that, we will need to create a new method inside our user controller object. Again, async find unique user, which will have again request parameter and response parameter. Now inside here, we just need to type, we can either, this method find unique, we will return us a single database record either by ID or a unique attribute. Again, here on the Prisma method, we are going to use the property user and the method find unique. This method, as the previous one create, again has some required arguments, and this time the required parameter is the where. And inside the where, we can either choose the ID or friend ID. I'm going to use the ID, but before that, I'm going to get the params from the request.params object, and I'm going to get the ID. So param ID, and this ID is going to be equal to this param, is going to be equal to this param ID, and I'm going to return us a unique user using the rest.json method from the Express. Now inside the user.routes file, I'm going to create a new route, routes.get, and I'm going to type just this, which is going to dynamically get us the ID from the URL. Again, I'm going to use the user control object and find unique user method. Inside Insomnia, I'm going to create a new HTTP request, but I'm also going to name it get unique. Now inside here, I'm going to type the same URL as in get all users, but I'm going to copy the ID from one of the users, for example devbit, and inside this I'm going to just type this, which is going to return us the unique user. When I click on send, now we have a unique user as a return object. One more thing to mention, for example, if I wrote here instead of ID, for example user ID, and I save it and I go to the Insomnia and press send, the server will return nothing. The reason for that is because in the find unique user method we use request.params.id instead of using the user ID. I would also suggest to make a new folder, for example models or types, and type everything for the request.body and request.params, but in this case we're not going to use it because we do not need it. You already saw that in order to return all of the users we can just type the find many method, but inside the find many method again we can use the where object, and inside here we can for example use the first name field, and that first name field for example needs to start with, and let's say the D letter, and inside get all users I'm going to send, and we are going to return all of the users because all of our users have the first name as which starts with the letter D. But for example if I change this here to B letter and press send, we're going to get a blank array or a array with no values inside it because none of our users have a name starting with the letter B. This means here that Prisma Client supports filtering on record fields and related record fields. We can either return all of the users by a single field value or for example multiple field value. What I mean by this, let's delete the first name here and use the AND property, and inside this AND I'm going to write that the first name needs to start with the letter D and last name needs to end with number 2. So inside Insomnia, let's click on send. As you can see, we only return the second one because the first name starts with the letter D here and last name ends with number 2. Now in order to update a single record, we can use the Prisma.model, in our case user.update method. But before that, again, let's make a new method. Now this method again has some required arguments. In this case required argument is where, because we need to update only a single record, not many of them. And in our case the ID, we are going to get the ID from the same way that we used in the find unique user, which is going to be param ID. Now the second required argument here is the data property that we already seen before. We need to update, for example, first name to be dev new. Let's return to our user the updated user. Inside the user.routes.ts file, we are going to create a new file which is going to have a put request, and second parameter is going to be our function user control update user. And I'm going to use the same ID as the before, and inside our I forgot to mention, I'm not going to use the static value here. I'm again going to use the first name from the request.body first name. So sorry about that. Now inside Insomnia, I'm going to create a new text, which is going to be of type JSON, and the first name is going to be the dev new. Save it and change from get to put, do not forget about that, and click on send. As you can see, the Prisma returned us the updated user. We can check that in get all users. But before that, let's delete this object that we created as argument and return all of the users. Click on send, and as you can see, the first name before was a dev1, now is a dev new. The last thing I'm going to show you today is I'm going to delete a single record. In order to delete a single record, you will need to use the Prisma.model, in our case the user, so Prisma.user.delete method. But before that, once again, let's create, and for the last time, a new method, delete user. Inside this method, again, I'm using the request.params.id in order to delete only a specific user, not multiple users, and the required argument inside the delete method is again aware, because we only want to delete a specific user, like I mentioned, not every user. Inside Insomnia, let's create a new HTTP request. This new request is going to be of a type delete, and again, I'm going to use the same ID that we use for a updating user and getting a unique user from an ID. But before that, of course, in user.routes.ts file, you need to create a new route of a type delete. That's it. Hopefully you have learned how Prisma works and why it is so good to use it. As you have seen throughout this video, in order to make CRUD application, you do not need a lot of knowledge, and you can make one less than 13 minutes. I did not make all of the routes, because this is not the point of the video. The point was to show how Prisma works and how to make really simple CRUD application. If you do want to see me make a full stack application where I will show you how to create records with one-to-many relationships inside them, or many-to-many or self-relationships, how to include them and many more things, make sure to subscribe to see it in the future. If you have learned something from me today, please make sure to subscribe to the channel, like the video, and comment down below what else you want to see from me. Take care and goodbye. Take care and goodbye.